This is lesson 97, number 6. And this is actually, I just want to bring your attention to this. I'm still going to work the problem, but I just want to show you that we did this in class, and also look on the opposite page. That is the exact same problem. It's got a 27, a 7, and a 5. Well, it has a 5. See, there's a 5. Oh, you can't see where my finger's saying. So on the opposite page, so in case you don't understand the explanation I'm going to give right now, just look on the opposite page in your book and you'll see that it's all worked out, and the author does a pretty decent job of explaining it. I'm going to use that to actually check myself. So we watched a video on this, and the video, remember the lady had that, she had that green, it was kind of like a tape that she could pull out, or she could make it shorter or longer. This is going to give the ambiguous case. We have side-side angle, or in other words, the angle that we have is not in between the two sides, so it's side-side angle. So that means we could have the ambiguous case. The side opposite is not longer than the side adjacent. If it were longer, then there'd just be one triangle, because it would be so long it would kind of stick out like this, and it wouldn't have room to swing around and make two triangles. We want to compare this side to the height and see if it's even long enough to make one triangle, because on the ambiguous case you can have 0 triangles, 1 triangle, or 2 triangles. So I want to check if this thing's shorter than the height. I don't even have to do the problem, I'm just going to write no solution. If it's longer than the height, then I'm going to have 2 triangles, and I'm going to have to figure out both triangles. So how do I get the height? Well, in the video, the lady just said, hey, just go like this, 7 sine of 27. That'll give you the height. So you might be a little skeptical about that, and maybe you want to see why it's that. Just, if you call this thing h for height, you know sine is opposite over hypotenuse, I hope. So you could say sine of 27 is opposite over hypotenuse, and then if you multiply both sides by 7, don't you just get that? So every time when you're doing these, just take the adjacent side times sine of the angle. It'll always work if you're in the side-side angle situation here. So 7 sine of 27. That gives me 3.1 something. 3.18. Okay, so this height is shorter. This side of the triangle is long enough that maybe it could make another triangle. You know what I mean? Maybe it's long enough where it could swing, because we don't know what this angle is. It could swing right in here and maybe make a second triangle with an obtuse angle. Okay, so the way I have it drawn here, we're using an acute angle. And so I'll go ahead and solve for the acute angle first. So what do we do? Well, we can still use law of sines. I'm trying to find this side right here is what I'm really interested in. I think I'll call it x. Okay, so I'm going to go, now I have to go a long way to get that though, because I'm going to have to use law of sines twice. Here's my pair. Sine of 27 is to 5. Now, I'm going to have to find, I only have this side, so I'm going to have to find that angle and then go 180 minus that and get that angle, and then I can finally do this. So I'm going to have to actually use this. I'm going to call it theta, this little angle right here. Sine of theta is to 7. Okay, so that's a pair. Okay, so cross product says 7 sine of 27 over 5 is sine of theta. So all I have to do is, and then I'm going to inverse sine both sides to find theta. So let's see if I can do this. 7 sine 27 divided by 5. I'm just typing this in on my calculator. And then I want to inverse sine answer. Alright, so I got this acute angle. It's 39.46. Now I can check all my work because it's on the opposite page, right in my book. Okay, so I'm saying that theta is 39.46. Okay, so if that's 39.46, then I can find x on my acute triangle here. That's 39.46. So now let's do log signs again. I'm going to say, oh wait, no, I'm going to use, I need to find this angle up here, don't I? So let's go 180 minus the other two angles and we'll find it. 180 minus 27 minus 39.46. Well, that gave me, I got about 113.54 up here. Doesn't look like it. Did I do something wrong? Let's see. No, that's right. Not drawn to scale. Okay, so I can use this angle that I have here to help me find x, because now I have, you know, this pair right here. So I can say sine of 113.54 is to x as, let's just use sine of 27 is to 5. I like to avoid using the decimals if I can. So this says 5 sine of 113.54 over sine of 27 is equal to x. Okay, so 5 sine 113.54 divided by sine of 27. I'm typing this in my calculator. Equals. I got 10.09. And so I can check it so easily because right on the same page, look, the same exact problem right there. They rounded it. It was, I had 10.096 blah 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 blah, right? So they rounded it to 10.10. Okay, so that's so x right here is 10.10. That's actually one of the answers they want. They want this bottom side right here. Now I'm going to draw the so that's for the acute triangle. Now I'm going to draw a triangle. Actually, it's not acute, is it? Because that's an obtuse angle in here. But there's this other triangle. If this is 7, see, I should have made that look a lot smaller, huh? 27. Let's make this look longer or something. And then remember the 5, I said it could swing around. Maybe it's going to swing out over here. So I'm going to make it look like it's kind of coming in over here. Okay, so that gives this thing right here, this angle is now obtuse. The acute angle that we got was 39.46. I get the obtuse angle by going 180 minus 39.46. 180 minus 39.46. That gave me 140.54. And I can always keep checking in my book. This exact problem is right on the opposite page, and I can check and I can see how they rounded it and everything. Okay, so I know this is this side. It's not drawn to scale exactly, but there's 5. I'm going to call this little side x. This angle, I want to get that. So that's why I got this angle, so I could get this angle. So now we're going to go 180 minus 27 minus 140.54 is not going to be much of an angle. It's 12.46. And again, I can check that by just looking in my book. It's right there. This whole problem's worked out right here. Okay. I'm going to have to do part 2 because my time is running out on YouTube. So I'll finish this in the next video.